In this video, I'm going to show you how to create the air motor assembly. First, you need to download all of the air motor parts off Polylearn. You need to go ahead and also put all your parts in one file folder and work with all of your files out of one file folder. Also, try not to rename your files after you start creating the assembly, or you'll have to reassociate these files later on. So when I open up the air motor parts, you're going to see I've got the crank disc, the cylinder, the dowel pin, the flywheel, the frame, the main shaft, the piston, the set screw, shoulder bolt, spring, the wood screw, and the wood base. Once you have all of these parts downloaded, you can then open up SolidWorks. When you open up SolidWorks, you're going to want to go to File and New. We're going to pick Assembly. Press OK. Now, the assembly environment comes up. You'll see we have the Windows File dialog box opens up. It allows me to start inserting parts. At this point, I'm going to hit Cancel, and I'm going to press X on the Begin Assembly. We're going to look at a few things before we start assembling. Remember, the assembly environment has the assembly ribbon bar here, which allows us to insert components, mirror or make patterns with components, move components or rotate them, and then also create an exploded view. So we're going to start assembling parts in this environment and then create an exploded view so we can show it in the 2D drawing environment. Now, looking over here on the file tree, you're going to see we've got our mates, our origin, and our planes right now. So the first part we bring into the assembly is our base component. In order to bring that base component in, we have to hit the Insert Components button and go select our files. So we go find where we've saved everything. And for the air motor, the base component is the wood base. So what we're going to do is we're going to insert the wood base by pressing Open. And we're also going to orient the base properly. So looking at this, when we place the first part in the assembly environment, it becomes fixed. We can also float it and move it around, but it's easier just to go ahead and orient it right now using the X, Y, and Z rotate buttons here. So looking at the part, or that base, and looking at the isometric view, if I go back to the drawing packet, what we're trying to create here, give me 1 second. If we look at it, we'll notice that the longer section here is towards the front. So moving back to SolidWorks, you're going to see we need to rotate around the Y-axis in order to have the setback for the holes towards the left side there. Once you've rotated your part 180 degrees, go ahead and click your left mouse button, and that fully positions the base part. How do I know it's fully positioned? Well, I look over in the file tree right over here and I see that there's an F right there. Realize that any time I can right click, I can float my base component, which gives it a negative sign because now not all 6 degrees of freedom are constrained. And I can mate using features in my part environment from the base. In fact, I could mate coincident. I could make the assembly's origin coincident with the wood base's origin. Check mark. Check mark. Now that I've done that, that didn't constrain all 6 degrees of freedom, so it still has a negative sign. However, I'm happy where it's located, so I'm going to right click and fix the base part. Remember, you want to have a fixed part that you build everything off of. Well, now that we've got the base created, let's move on. Let's go ahead and open up the next part. Looking at the assembly drawing here, I'd say the frame would be the next piece that we need to assemble. So move back to SolidWorks. We'll go to Spacebar, bring up the View tab and go to Isometric, and I'll hit the Insert Components button. So the next piece we're bringing in is the frame. So when I hit the frame, when I select frame and press open, I bring the frame in and place it very close to where it's going to go. In fact, I could have rotated it around when I first placed it, but I like to just place my parts in there and go ahead and start to constrain the degrees of freedom with the mate button right up here. Alright, so now that the part's been inserted, we'll go ahead and click on mate. We'll select concentric mate, and we'll mate the cylinder here with the cylinder right there, concentric. When I hit check mark, and I grab my part, notice I've constrained 4 degrees of freedom. All I can do now is move up and down linearly or rotate. So to go ahead and constrain another degree of freedom, I'm going to select concentric. I'm going to line up that cylinder with that cylinder. When I hit check mark, notice I've constrained 5 degrees of freedom and I only have my 6th degree of freedom left. Well, last but not least, we know we could hit coincident. We want the bottom face coincident with the bottom face of the frame there. So when I hit check mark, rotate it in, click off of mate, you'll notice the frame no longer has a negative sign there because it's fully positioned. All 6 degrees of freedom have been constrained on the frame. Excellent. Now we're ready for our next part. So our next part is going to be a screw. We're going to put the screw in here, the wood screw, and line it up with the hole right there. So then to insert the wood screw, we go to Insert Component, we select Wood Screw, and press Open. Now notice the wood screw is in the correct orientation, so I'm going to go ahead and click check mark. And to line this screw up, if you think about it, when I select mate, I go to concentric, and that circle is concentric with the cylinder right there. Check mark. Now, we've got to look at a couple of things here. Notice the base has draft on it, the frame. So when I bring the wood screw down, it actually doesn't hit coincident. In real life, the wood screw is going to basically deform slightly and become parallel with that top face due to the forces. However, we can't do that in the SolidWorks assembly environment, so what we're going to end up doing is we're going to do a tangent relationship. We're going to make that face tangent with that edge right there. Check mark. What that does is it brings the head of the screw up to the edge, the tangent edge, with the face right here like it would in real life before we actually physically deform the screw. Now, screws tend to rotate. So we're not going to lock the rotation on this assembly. So this one's going to have 1 degree of freedom that's not been fully constrained, because we're going to allow it to rotate like it would in real life. So at this point, I've fully inserted my screw. Now I notice there's one on the other side that's symmetric about a plane. So instead of creating 2 relationships, I can go up to the mirror components. I can select my mirror plane to be my front plane, and my components to mirror would be my wood screw. When I hit check mark, it puts a wood screw on the other side of the assembly there, and there's no need to go ahead and create 2 more relationships based off that first one. Alright, now it's a good idea to save often. So I'm going to go File, Save As. I'm going to call this Giorgio Assembly Air Motor, and press Save. Excellent. Remember, it's a good idea to save often. So now looking at the air motor, I've got to go ahead and create a couple more assemblies. I could do sub-assemblies outside this assembly environment, or just physically put it all together now. For example, I could press fit the main shaft into the flywheel as an assembly, and then bring it into this assembly file as a sub-assembly. but it might be easier for now to just insert all the components into one file. So let's go ahead and go to Insert Component. We're going to make the subassembly within the assembly. So I'm going to bring in the main shaft, open, check mark, and I'm going to insert component. I'm going to bring in the crank disc, open. Then I'm going to bring in, insert component, the flywheel. Hopefully your computer has enough RAM to do this. There we go. Well, looking at these components, this is a subassembly right here. So what we're going to do is we're going to insert the shaft onto the flywheel, and then the crank disc onto the shaft, and then into the assembly here. So to do this, I'm going to go ahead and go mate. I'm going to make concentric this shaft with this hole. Now, looking at the part, this would be the wrong way. If I go back to the assembly drawing, my exploded view, you're going to notice the rounded edge of the flywheel faces the actual frame right here. So moving back to the SolidWorks assembly, you'll see this rounded edge needs to be flipped. In order to do that, it's the reverse mate alignment, or flip. So when I hit this button, right here, it flips the mate alignment. It's also located in the design tree over here in the left corner. So when I hit check mark now, you'll see I've located the shaft onto the flywheel right here. So our next step would be to go ahead and hit the coincident button, make this face coincide with this face, check mark. We'll do that through a press fit. Now you can see we have fully placed the flywheel on the main shaft. So the next step is going to be to make concentric the shaft with the frame. Now looking at this relationship, it's backwards, so we're going to flip our mate alignment. We can do it right here, or we can do it over here. Check mark. Now, as I insert the shaft into here, we have to go ahead and position it at an appropriate location. So, I could do two things. There's a tab option, or I could just know the distance that it's going to float back and forth. What we're going to do is we're going to end up assembling it completely and analyzing the assembly with the evaluate tool to figure out the distances it needs to float. So for right now, I'm going to slide it in. Or I could actually show it to you at this moment. So if I move this back out, I see that I've got my evaluate tool over here. When I go out of mate, I can use this to measure. In fact, if I measure, I can measure that distance from there to there. And if you notice, it's at 2.45. If I needed to change my precision in my measurements there, you can hit that button and go to Custom Settings, Decimal, 5 places. And what that'll end up doing, inches, decimal. When I grab a distance, it's going to go off those, should give me a distance with that accuracy. Give me 1 second. Measure. So we go from there. To there, you'll see I get my larger accuracy right there for my center distance. So it's 2.455. Now, I know that distance, and I also am going to measure the distance between where the main shaft would right up against this edge and that distance. Whoops, I hit the wrong button. Press escape to cancel. So we hit measure. We can go from here to there. and it's 248. So we have, if you look, we have about 30 thou difference right there. So we have 248, so 30 thou. So we're going to have 15 thou offset. So what I can do is I can set up a relationship that allows it to shift back and forth about 15 thou between the surfaces. So to do that, we're going to move over here. We're going to do assembly. We're going to hit mate, and we're going to do a distance mate under the advanced mates. In fact, it's a limit distance mate to where we get them really close. If I come in here and I clear selection, I want to go from that edge to that edge. I want to set it at, remember, it was 15 thou back and forth, so 30 thou overall, 0.45 to 0.48. So I could set this at 15 thou right in the middle. And I know the closest would be 0. The farthest away would be 30 thou. When I hit check mark, it sets it at the 15, but it allows it to shift only that distance the shaft would physically move in the model. So it goes those values right there. That it goes from flush to back and forth. So that's how I set the distance and not allow the flywheel to exit out of there. Now remember, the flywheel is always going to rotate on the shaft. The problem is, when it gets press fit, the flywheel and the shaft need to rotate in relationship to each other. In order to make them rotate with relationship to each other, I've got to go ahead and mate them to each other, other than just concentric. So what I can do is I can hit mate. I can go through and I can pick my flywheel, my front plane. I can make that parallel to my main shaft's front plane. Oops, cancel. I hit the wrong plane. So I want to make my flywheel, my top plane, parallel to my main shaft's top plane. Picked the wrong one before, sorry. So when I hit check mark and check mark, now when I rotate my flywheel, the planes have to stay parallel, therefore they're going to basically rely on each other. Their degrees of freedom are constrained with respect to each other. So at this point, I'm ready to go ahead and continue assembling. So what I need to do is I need to click on my mate tool. I'm going to go ahead and I'm going to mate my crank disc concentric that surface to that surface. Now looking at the part, you'll notice that the flywheel is flipped to the right side, or the crank disc, sorry. We'll hit check mark and check mark. So it's lined up correctly, except the flats now need to match and line up. So what I can do is I can do a parallel relationship between that face and the bottom face right there. Check mark. What that ended up doing was aligning those two pieces. Now last but not least, we know that when we assemble the crank disc on the main shaft, we make this back face coincident to this face right here. Check mark. Now if we go back, we look, you'll see we've got our flywheel, our crank disc, and our main shaft assembled appropriately. Notice they're never going to be fully fixed in their degrees of freedom because they're always going to rotate. Excellent. Now in order to keep the crank disc on the main shaft, we use a set screw. So I'm going to go ahead and hit insert component, go grab my set screw, press open, and place it in the window here. Now it's a common mistake for students to put the set screw in upside down. So what we want to do is we want to go ahead and do mate. We want to make this circle concentric with that circle. And before we hit check mark, we want to make sure the hex head is pointing upwards. So notice, downwards, upwards, check mark. Now I pull the set screw up and out of the hole there, and I hit the coincident relationship. So I want to make the bottom flat coincident with the bottom piece of the set screw. Check mark. What that does is it sets the set screw in place. Now remember, the set screw is always going to rotate, so we're not going to go ahead and fully constrain all 6 degrees of freedom, because it still rotates on the main shaft. Excellent. Well, the whole bottom end of our air motor is put together. Now we're going to just slowly build from the bottom up on this assembly. So the next piece that we need is the dowel pin. The dowel pin, if we click on X from the mate, gets inserted by hitting the Insert Components button. Then we go over to dowel pin. Press Open. At this point, we place the dowel pin in the window, and we're going to go ahead and do Mate. We're going to select concentric. We're going to pick that shaft or that cylinder with this cylinder right here. Check mark. Now we're going to pull the dowel pin out of the crank disc, and we're going to select coincident, because when we press fit this dowel pin into the crank disc, that face and that face are coincident. Check mark. Now spacebar, isometric view, and you'll notice our air motor is doing well. Now what we've got left is we've got to put a cylinder in it, and the bolt and the screw, and then the piston. Let's actually do the piston first. So to do that, you'll see that we're going to go ahead and go to Insert Component. We're going to select Piston, Open. I'm going to go ahead and just rotate it around the Z in order to get it aligned, and then around the Y to fully align it. Makes it easier to position. But remember, it still has all 6 degrees of freedom unconstrained. So when we go ahead and we mate this part, I can select on Mate. I'm going to make concentric this cylinder with the cylinder inside the pin. Check mark. Now it's going to slide back and forth, and the actual cylinder will keep the piston in line right here, so it doesn't have anything constraining it in this direction or this direction. So that's really all we need to do for the piston at the moment. Well, next we have the cylinder. So when I hit Insert Component, I go find the cylinder and press Open. I bring it in, and I start lining up bolt holes. So really, when I assemble this piece, I'm going to select Mate. I'm going to go concentric. I'm going to make that hole concentric with that hole. Check mark. Now I pull them apart, and really what keeps it aligned is if I go concentric, I make that concentric with that. That's what actually keeps the air motor going, if you think about it. However, we got to keep it from pulling off from this face. To do that, we're going to do coincident, that face, and that face. Check mark. Now, looking at it, those are all the relationships the air motor needs in order to run fully, because it pivots off this axis with the concentric relationship. The coincident relationship keeps the cylinder from removing itself from the frame, and then the piston keeps the rotation down here in a line. So truthfully, we're just about done with this air motor. However, when I move around to the back, I notice nothing's holding the cylinder onto the frame. So we've got to take care of that. To do this, let's go ahead and Insert Component. We'll grab the shoulder bolt, Open, and Insert Component. We'll grab the spring, Open. Now the spring, if we look at it over here, has a sketch already created in the part environment that's hidden. We're going to use that sketch to line up some things. So when I select Mate, I'm going to use the sketch inside the spring. I got to show it. And I'm going to align that circle concentric with the shoulder bolt. And then I'm going to plug my battery in. So once that lines up concentric, we're then going to line up the flat on the washer. So give me one more second with this battery charge. So we make the springs sketch concentric with the shoulder bolt. Now we have to make coincident this flat with the bottom flat on the shoulder bolt. At this point, I notice the sketch is still showing. I'm going to right click and I'm going to hide the sketch for that circle because we no longer need that circle for the spring. Now in order to make the shoulder bolt, I'm going to make concentric the shoulder with the bore. Now notice the part went inside the other part. This could be a problem, but I could always right click. I could hide. I could grab the other part. And in order to unhide it, I have to go back to my design tree, right click, and then I can show it again. So a lot of the times you'll need to hide and show stuff to assemble. Now the last relationship we're going to do is really assembling the shoulder bolt. So it needs to go ahead and be coincident. This bottom flat face is coincident with this bottom face in the frame that it actually touches. Bam. Check mark. Now, shoulder bolt, actually, Control Z, that was the incorrect surface. It's this bottom surface right here. So it's coincident, that surface with that surface. Check mark. Now we have a fully assembled air motor. So when I hit spacebar and normal to the front face, you can see there's a slight amount of gap in between the two pieces. It fully rotates, it shifts back and forth between the two stops, and the air motor will run if we added a motor to it. In fact, how do I know it'll run? When I hit spacebar and isometric, I place it in the isometric view, and what I can do is I can do some other things with this air motor. In fact, I can go to my evaluate. I could go through, I could do allowance and clearance validations so I can see how much clearance I have or interference in my assembly. And I could compare those to my theoretical allowance and clearance calculations. Wow. There's a lot of things I can do. I can move components, rotate components. I can basically create other reference geometry. I can do CAM programming in here. There's a lot of things we can do. But what I want to show you now is I can go ahead and I could do a motion study if I wanted to. I could add a motor to the part. However, you can only do this if you fully assembled the air motor. So when I pick on motor, I could say, hey, I want to drive my flywheel at 5,000 RPM. It'll even do graphs for you. So if I move that component to move relative to the frame pretty much, right? You'll see we now have the air motor going at 5,000 RPM. So you can do all sorts of different analyses with motion and so forth. But what I want you to do, let's go back to the model. Remember the motion studies where we added the motor. Add a motor and you can do all sorts of different things. What I want you to do is create an exploded view so we can see how the parts actually fit together. So I'm going to press save at the moment. Save all. In order to do an exploded view, we have to hit the exploded view tab. And remember, you want your exploded view to look very close to what you see right here. Not exactly, but close. So to do that, moving back to SolidWorks, we're going to create a bunch of explode steps to pull this air motor apart. In fact, in order to pull it apart, the first thing I would probably do is go through and pull out the set screw. So I would take that set screw out. Then I would probably take this bolt and, moving down over here, the spring out together. Spacebar, isometric. At this point, I would probably remove the bolt from the spring, then maybe pull the flywheel backwards along with the main shaft. Now that the bolt's removed, we can pull the cylinder upwards and maybe over a little bit, pull the piston out and over, the crank disc out, the pin out, spacebar, isometric. Remember, this is exactly what you're going to see in the isometric view. Kind of compare it. And maybe a wood screw or two off the part. Spacebar, isometric. And then maybe the base downwards a little bit. Spacebar, isometric. But that's how you create an exploded view. I didn't spend a lot of time creating this one. Spend some time spreading out your parts so it looks very close to like the one you see in the air motor manual or the class manual. So you can go back to your explode steps at any time, and you could edit the step if you wanted to make it 1.25, slightly different values. You could do that. You could change the amount of degrees things are basically rotated and so forth. So you can go through and change the way the step works. So remember, that's going back to any step anytime and editing the step if you didn't like exactly where you placed it. When you're all done, you hit the check mark and you have an exploded view configuration. How do I know this? I go to the configurations tab, and under exploded view you'll see I can animate collapse, and it puts it back together exactly how I pulled it apart. Or I can right click. Actually, I have to close that piece. I can right click, animate explode, and it pulls it apart exactly like I pulled it apart. So that's everything you need to do with the air motor assembly in the assembly environment. Join me for the next video and I'll show you how to do a 2D engineering drawing and make assembly drawings and exploded assembly drawings with a parts list and a bill of materials. Thank you for watching, and I hope you have a great day. See you in class.